Have you ever noticed how, over the last few years, it feels like the whole world has been holding its breath, focused on just one major health crisis? The COVID-19 pandemic completely shifted our global focus, and understandably so. It was an unprecedented challenge that required an all-hands-on-deck response. But while we were fighting this new battle, some of our oldest enemies didn't just disappear. In fact, in the shadows they began to creep back, stronger than before. One of these ancient foes is malaria. For many of us, malaria might feel like a distant problem, something you only read about in history books or hear about in far-off countries. But the reality is, it's a devastating and ever-present threat for billions of people. And the disruption caused by the pandemic has made the fight against it even harder. Healthcare systems were overwhelmed, supply chains for essential medicines were broken, and prevention programs were put on hold. As a result, progress stalled, and in some places, we even lost ground. But today, we're not here to talk about setbacks. We're here to talk about a monumental breakthrough. A turning point in a fight that has lasted for millennia. Because after decades of relentless research and countless setbacks, we finally have it. The world's first ever approved malaria vaccine. This isn't just a small step forward. It's a giant leap for global health and a beacon of hope for millions. So, how do we get here? And what does this incredible achievement really mean for the future? Stick around as we dive into the story of one of humanity's greatest scientific triumphs. To truly grasp the magnitude of this achievement, we first need to understand the sheer scale of the enemy we're up against. Malaria is not just some minor illness. It's a global health catastrophe that unfolds every single day. Each year, more than 200 million people, that's more than half the population of the United States, fall ill with malaria. And for many, it's a death sentence. The disease claims approximately 500,000 lives annually. Let that number sink in. That's like a major city being wiped off the map year after year. And the most heartbreaking part? The vast majority of these victims are children under the age of 5. These are toddlers and infants who haven't even had a chance to live, whose futures are stolen by a tiny parasite. In many parts of the world, particularly in sub-Saharan Africa, malaria is a constant, terrifying presence. It fills hospital wards, drains family finances, and keeps entire communities trapped in a cycle of poverty and disease. So what exactly is this disease that causes so much devastation? Malaria is caused by a microscopic parasite called Plasmodium. There are several species, but the most deadly is Plasmodium falciparum, and the mastermind behind its delivery system. A tiny, unassuming insect, the female Anopheles mosquito. When an infected mosquito bites a person, it injects these parasites into their bloodstream. It's a biological invasion of the most insidious kind. Once inside the body, the parasites embark on a destructive journey. First, they travel to the liver, where they multiply silently, growing in number from a few dozen to tens of thousands. This is the incubation period, where the person feels perfectly fine, completely unaware of the army gathering within. After about a week or two, this army is unleashed. The parasites burst out of the liver and invade the red blood cells, the very cells responsible for carrying oxygen throughout our bodies. Inside the red blood cells, they multiply again, feeding on hemoglobin until the cells rupture, releasing a new wave of parasites to infect even more cells. This cycle of invasion and destruction is what causes the classic symptoms of malaria: intense, recurring cycles of fever, chills, and violent sweating. But it gets much worse. As red blood cells are destroyed, it leads to severe anemia. The parasites can also cause the infected blood cells to become sticky, clogging up small blood vessels and cutting off blood supply to vital organs. When this happens in the brain, it causes cerebral malaria, leading to seizures, coma, and often death. For pregnant women, it can cause severe complications for both mother and child. It's a brutal, relentless disease. For centuries, our main defense against malaria has been a collection of preventative measures and treatments, but each has its limitations. We've used mosquito nets, insecticide sprays, and protective clothing to avoid bites. These are crucial, but they aren't foolproof. Mosquitoes are clever and can develop resistance to insecticides, and a single forgotten net can be the difference between life and death. When it comes to treatment, we've relied on anti-malarial drugs. You've probably heard of quinine, one of the oldest treatments, derived from the bark of the cinchona tree. More modern drugs, like artemisinin-based combination therapies or ACTs, have been the frontline treatment for decades. These drugs can be life-saving, but they come with their own set of serious problems. First, they're not always effective. The Plasmodium parasite is a master of evolution. It constantly mutates, developing resistance to the drugs we throw at it. In some regions, especially in Southeast Asia, we're seeing alarming levels of drug resistance, making treatments less and less effective. Some studies have shown effectiveness rates as low as 72%, which means for more than a quarter of patients, the medicine simply doesn't work well enough. Second, the side effects can be harsh. These are powerful drugs designed to kill a parasite living inside our own cells. They can cause nausea, dizziness, headaches, and in some cases, more severe neurological or psychological effects. For a child already weakened by fever and anemia, these side effects can be incredibly tough to endure. Furthermore, the treatment regimens can be complex, requiring multiple doses over several days. If a patient feels better after the first day or two and stops taking the medicine, some parasites can survive, and a relapse can occur, often with drug-resistant parasites. This creates a vicious cycle. Given these challenges, the global health community has dreamed of a silver bullet for decades: a vaccine. Something that could teach our immune system to recognize and fight off the parasite before it ever has a chance to take hold. A vaccine could provide long-lasting protection, reduce the number of cases, and ease the burden on healthcare systems. But developing a vaccine against a parasite like Plasmodium has been one of the toughest challenges in modern medicine. Unlike viruses or bacteria, parasites are large, complex organisms with incredibly sophisticated life cycles and ways of evading our immune response. For over a century, the quest for a malaria vaccine seemed almost impossible. Until now. After decades of dedicated research, facing down one of the most complex parasites known to science, we are finally witnessing a historic breakthrough. This isn't just one vaccine. We're actually seeing the dawn of a new era with two groundbreaking candidates leading the charge. This marks a monumental advancement in our long war against malaria. The first to cross the finish line is a vaccine called eradicating, also known by its brand name Mosquito. Developed by GlaxoSmithKline over 30 years, it's the culmination of an incredible amount of perseverance and investment. In 2021, the World Health Organization made a historic recommendation for its widespread use in children living in regions with high malaria transmission. This was the moment we'd all been waiting for. The world's first ever approved malaria vaccine was finally ready for deployment. So how does it work? eradicating targets the Plasmodium falciparum parasite at its earliest stage, right after the mosquito bite and before it can cause illness. It primes the immune system to recognize a specific protein on the surface of the parasite, intercepting it before it reaches the liver to multiply. Think of it as an early warning system that neutralizes the invader at the gate. In large-scale clinical trials involving thousands of children in Africa, the vaccine, given in a 4-dose schedule, was shown to prevent approximately 4 in 10 cases of malaria and about 3 in 10 cases of severe, life-threatening malaria. Now, you might hear 4 in 10 inches and think that doesn't sound incredibly high compared to, say, the measles vaccine. But in the context of malaria, this is revolutionary. When you're dealing with hundreds of millions of cases, preventing 40% of them means saving tens of thousands of young lives and preventing millions of illnesses every year. When used alongside existing tools like bed nets and seasonal preventive drugs, its impact is even greater. It's not a perfect weapon, but it's the powerful new tool we've desperately needed. And the story doesn't end there. Hot on the heels of eradicating is another, even more promising vaccine called R21 Matrix M. Developed by the University of Oxford, the same team that gave us the AstraZeneca COVID-19 vaccine, R21 has shown even higher efficacy in clinical trials. Data suggests it could be over 75% effective at preventing malaria in the year following a 3-dose course. This is a phenomenal number that could dramatically reshape the fight against the disease. What makes R21 so exciting is not just its efficacy but also its potential for massive scale production at a very low cost. The Serum Institute of India, the world's largest vaccine manufacturer, is ready to produce over 100 million doses per year. This combination of high effectiveness and low cost, high-volume manufacturing could be the ultimate game-changer, making protection accessible to every child who needs it. The WHO has also recommended R21, giving countries a second, powerful option. The approval and rollout of these vaccines are more than just a scientific achievement. They are a symbol of hope. For families who have lived under the constant shadow of malaria, this means a future where their children have a much better chance of growing up healthy. For healthcare workers on the front lines, it means fewer packed hospital wards and more manageable caseloads. And for the world, it means we are one giant step closer to the ultimate goal, a world free of malaria. The road ahead is still long, but for the first time in history, the path is illuminated by the bright light of a vaccine. Thanks so much for watching. The fight against diseases like malaria takes a global effort, and just by learning about it, you're a part of that. If you found this video insightful, please give it a thumbs up and consider subscribing for more stories on science and global health. Hit that notification bell so you don't miss our next video. Stay curious, stay informed, and we'll see you in the next one.